Hello everyone and welcome to the channel. In this video we are going to use Python to solve routing optimization problem, and we will simulate the final solution on the map like this one. We will be using Starbucks dataset, and we are assuming that we are a supplier for Starbucks London and we have to deliver some sort of material to all Starbucks locations in London. The overall goal is to minimize the travel distance by our driver and therefore to minimize the overall cost. So let's see how to do this. First, we need to install some libraries or to import some libraries. We need pandas for data frames. We need NumPy for some numerical operations. And then we need some libraries for plotting. We need matplot, Seaborn for the heat map, and Folium for the maps. And then we need also NetworkX and OSMNX for the graphs and to have access to distances and to convert the maps into graphs. And finally, we need the optimizer from Google. It's OR tools. So this is going to be our solver for the optimization problem. Next, we need to import our dataset for Starbucks locations in London. We will import it from the CSV file. I will leave the link for this file in the description of this video. And then we will select only the columns that we need. So we will select only the city, the street address, the latitude, and the longitude for each store. And then we will just rename the latitude and longitude into X and Y just for simplicity. And also the index, we will rename it as ID. As you can see here, we have the ID, city, street address, Y and X as the latitude and longitude. Now let's copy the data frame that we have created, and we will add a new column and we name it color, and then we will assign a red color for the first location or the first store to be our starting point, and then we assign a black color for the rest of the locations. In the next step, we will need this when we visualize the points on the map, so that our starting point will be a red circle, and then the rest of the locations will be black circles. Now let's visualize the locations on the map using Folium. We have to define the starting point. Remember that we already defined it in the previous step. And we have to also define the style and the starting zoom. After that, we have to pass the data frame that we have copied in the previous step, data, and then we go row by row and pass the latitude and longitude, which is Y and X, and also the color for each one, which is black, as we mentioned the previous step, and also to mention the radius of the circles. Let's now run this, and as we can see here, all the Starbucks locations in London are in black circles, and the starting point is in red. Now we will be using the OSMNX library to create a street network graph around our starting point. and with a maximum distance of 10 kilometers around the starting point. And the network type is drive, so that it considers only the driving streets, not the walking or the biking. And for each edge in this graph, we need to add the information about the speeds and the travel times. This is important for solving our optimization problem later on, based on the travel times or the speed or the distance. And then we will need to just plot this network graph in, in black, and specifying the node size and the node color as white, and also the dimension of the graph. So let's run this, and as we can see here is the network graph. Now, for each Starbucks location X and Y, which is the latitude and longitude, we need to find the nearest corresponding node on the graph. Because from now on, we will be working on the graph rather than the map. So let's go and find the corresponding node for our starting point, and then to do the same with all other locations, we find the nearest node on the graph. And also we need to drop any duplicates. For instance, if two locations are sharing the same node on the graph as the nearest node for both of them, then we drop the duplicate, and then we keep only one node. So let's go and do this, and we can see now here for each location X and Y, we have a corresponding node on the graph. Now, since we have the graph and we have all corresponding nodes to our Starbucks locations, now it's time to go and define a function to calculate the shortest path between a given two nodes, and also given the graph. So we'll define a function called f, taking two arguments, a and b, which is going to be two pair of nodes, and then using networkx library to calculate the shortest path length between a and b given the graph. And then the method is the algorithm used, and giving a weight to the travel time. If the distance successfully calculated, it will return D. If not, it will return none, if the path does not exist or something. After that, we create a distance matrix. So we create a NumPy array, and then we loop through all possible combinations of nodes, calculate the distance, calling the function f for all possible combination of node pairs, and then store it in the NumPy array. Once we are done, we convert the NumPy array into a pandas data frame. Now let's go and run this. As you can see, the distance matrix. Now let's plot the heat map for the distance matrix. So we copy the distance matrix into a new matrix called heat map, and then we create a new column for the colors, and then we loop through all the elements in the distance matrix, and we assign a value between 0 and 1. If the value for the distance is null, we assign 0.3. If the value is infinite, we assign 0.7. If the value is not 0, we assign 0. Else, we assign 1. So we will use these values later in the next step to make the color gradings for the heat map. Next, we create a plot with the size of 10 by 5 inches. And then using the Seaborn library, we create the heat map. So we pass the new distance matrix with the assigned numbers for creating the colors. And then the Vmin and Vmax is the minimum and maximum for the color gradings. And then we set the color bar to false, and they specify the axis. We run this, and we get the heat map with the white area, only the zeros between the node and itself. Now we need to round the values in the distance matrix to integer, because for the optimizer later on, it will give us an error if we leave it as float. So we need to round it to the nearest whole integer, and then convert it into integer type. Remember that for this optimization problem, we are assuming that we are using only one driver who will be delivering some sort of material or something to all Starbucks locations or stores in London. So let's see how many locations that our driver has to visit. So we have a starting point, total locations of 19 to be visited using only one driver, and then we have to optimize the distance traveled. Now, since we have the list of nodes to visit, number of drivers, and we know the starting point, we pass them to the routing manager. So this class is part of the OR tool optimizer from Google. So we pass the list of node drivers and the starting point to the manager, and then we pass this manager to the routing model. Now we define a function called getDistance that takes two pair of nodes and return the distance between these two nodes from the distance matrix. Once we define this function, and then we need to pass this function to our model so that our model will be using this function while searching for the optimized solution. Also, we need to set the parameters that will be controlling the algorithm behavior while searching for the optimized solution. And also we need to specify the first solution strategy. In our case, we will use the path cheapest arc strategy. Now it's time to solve the problem using the model and the parameters that we have already defined. We will start at the index 0, and then we defined new two empty lists, one for the indexes and one for the road distance. And then we will initiate the model into while loop, so to loop through all indexes and to find the optimized solution. So for each node, we will calculate the shortest distance, the shortest distance to the closest node, and so on and so on every time, and then it assign the distance into the road distance list, and so on. It will keep accumulating the distances until we reach to the final index where we get the optimal solution, the optimal route, and we will end up having the total route distance, and then we will just convert it into kilometer, and then we print the associated indexes, the distance, the total distance in kilometer, and then the number of locations visited. So as we can see, here is the optimized route, the solution for the problem, and the total distance traveled is 7.6 kilometers, and 20 locations have been visited. Now let's get the corresponding nodes for the solution. So we convert the indexes that is given by the solution into the corresponding nodes. So let's do this, and here is the solution in terms of nodes. Now let's find the path for the overall solution so we can draw it on the map. Let's define a function. We call it getPath between nodes, and we pass the list of route, which is our solution from the previous step. Then we start an empty list. We call it list of paths. And then we initiate a for loop, so we can loop through our solution, which is composed of 20 nodes. And then for each node and the node after it, we use network X to find the shortest path between these two nodes. And and then we assign the solution, the path for between these two nodes. We assign it to the list of paths, and then we go back again and loop through all nodes, each node and the node after it, find the shortest path between these two pair of nodes and assign it to the list of paths. Once we have the list of paths for the overall solution, and then we take this path and then we plot it on the map using Folium again, so we can have or visualize our solution on the map again. As you can see, here is the path for our solution visualized on the map. Now, since we have all the paths for our solution, let's define a function to animate or simulate this solution on a map. So we define a function, we call it animation multiple path, and then we define empty data frame, and then using for loop, we will go through all the paths in our solution one by one. For each path, we need to know what is the starting node, what is the end node, and what is the starting x coordinate, which is the latitude, what is the starting y coordinate, which is the longitude, and then what is the end x coordinate, and then what is the end y coordinate, and also what is the length of that path, and also what is the time, travel time for that path. So we are creating empty lists for each one of these variables, and then using another for loop to go through all these paths one after one, using the zip operator to get all these variables and to append them one by one to the empty lists. By the end of this for loop and this function, we should get a data frame with this all these variables together, and we are creating columns corresponding to these variables, and we concact the empty data frame with the data frame that we are getting from this for loop, and finally we return the final data frame, which includes all the variables that we need in one data frame, which we will be using in the next step to simulate them on the data frame or in the map. Now let's call the function, the animation function that we have defined, so we can have all the information that we need together in one data frame, and so we can prepare it for the next and last step, which will be animating and simulating all the paths on the map. And also we need to define the first node and the last node, so we can give them a unique color on our simulation on the map. Before we go to the last step, which is the simulation or the animation, let's have a look at the data frame that we have created, which we will be using for the simulation. So as you can see, for each path, we have the starting point, the end point as a nodes, and then we have the corresponding x and y for the starting point, and the corresponding x and y for the end point, and we have the length of that path and also the travel time. So we will be using this data frame to create the animation on the map. Now the last step is to simulate the solution on the map. So we create a data frame for the starting point and the end point. And then we create a scatter plot using the Plotly Express library. We pass the data frame from the previous step with all information that we have gathered, and then the longitude and latitude around the starting point, and the starting zoom is 15, and the dimension of the plot, and the animation frame will be based on the ID, and the style for the map is Carto Positron. After this, we start adding a marker for the driver, and then a trace and marker for all the other points. So we are passing the data frame for all the other points, and we're giving them a size of 10 and a black color, while the driver will be, the marker will be a size of 12, a little bit bigger. And then similarly, we add a trace and a marker for the starting point, giving it a red color and a size of 15, bigger than the other points or the other markers. And similarly, we are adding a trace and marker for the endpoint, giving it a size of 15 and a color of green. And finally, we add the route. And now let's finally run this and see if it works. Whoops, we have a little problem here. I think is because of this little space here. So let's fix it and see if it works. Oh, we have another problem. Oh, it's marker, not maker. My bad. Let's fix this and run again. Finally, it's working now. As you can see on the map, the simulation is working. The driver started at the red circle, which is the starting point, going through all the Starbucks locations, the black circles, and then we'll finish at the end point, which is the green circle.